Hello everybody, my name is Chandra and so now our next topic is data preparation phase 2 modular data, and let's look at this topic. So in this video we have an agenda: how to partition the data, how to balance the training data set, how to build a CART decision tree, and how to build a C5.0 decision trees and how to build random forest. So basically these all are below three are just an algorithms, and let's sorry look at this one by one. Okay, so how to partition the data. You can, if we have many ways to partition data. If we have a data frame or data frame and we have to split in the two groups, we can easily do it by using row index and in group form unique column values, and using predetermined size chunks, and by shuffling rows. So suppose let's we use the one of this method. Let's suppose we use a predetermined size chunk. Okay, so here this is the code. We are importing the libraries Seaborn and pandas and numpy. So you don't have to download it. You can just use this NIS to load the data set. So let's load it. After loading the data, we have this following output in the df, and to split the data we just simply do the sample that has a fraction of 0.6, and the random state will be 200, and lastly we will reset the index after splitting. So doing this we have the splitted data. As you can see, this is about 32,359. These are the below 4 index. Okay, so this is how we can partition the data. And okay, so our next topic is how to balance the training data set. So balancing the training data means sometimes we take the samples, and the suppose we have two classes there, and the one class has a large amount of uh, information, like one is unbalancing the other. For example, for in this definition, some of the most frequently occurring problem statement, common problem. Okay. When we observe in one class is higher than in other class, so a class imbalance exists. For example, suppose we have a data about fraudsters that fraud on credit and card transactions, like, so in this graph we can see there is no fraud, there's no fraud about 900 some 90,000 something, and and fraudster are only 400 in this sample. So this 90,000 and 400 are looks like imbalanced data we have. So how we can balance this data? We can balance this data by sampling more and more until unless we have the balanced data. Okay. So our next topic is how to build a CART decision. So this CRT, we can say is a algorithm that uses a classification and regression both at the time. It is also a predictive algorithm that can classify or predict the value, and explain how the target variable's value can be predicted. So based on another method, it uses a decision tree. Okay, where each is split into predictor variable, and each node has a prediction at the end. So for example, code related to this type of algorithm. So firstly, we are using sklearn tree. That sklearn is something you can use it sklearn documentation that has a lot of models here or libraries. So we can easily hit our model and classify and regulate the things, predict the things. And we are using the pre-processing for the pre-processing of the data. So firstly, we have defined the features that we gonna train to our model, and the target variable will be apple. Okay, these are the fruits, and we have flattened the feature. Okay, flattening like is flattening in the array form, you can say. And after that, we are connecting all the features with the target variables. Okay, by using this fit function, and L is nothing but a label encoder. So this label encoder is basically fitting this value, target value, and the flattened feature. And after that we encode feature and target value in the encode feature and in the encode target by transforming it. And after that we create a CART classifier that uses the decision tree classifier, and this CLF will fit this encoded feature and this target as well. Okay, so after fitting this, we have the new instance that we are going to test this red large. It is written here, so here we can see this is the red large. So this is supposed to give the output apple, and let's see. So this will give, so we are getting new instance of this, and the predicted food type will be, we are using this classifier to predict the value by using this variable instance, and by decoding, and we are using inverse transformation to get the key value. And after that we have the predicted food type. Let's see, we have the predicted food type apple, or as it is saying, suppose we small, then it will give a strawberry, as so it is the third index, and then this the third index type. Okay, so that's about CART decision tree. So the next thing is how to build C5.0 decision tree. So C5.0 is a method in a decision tree. It builds basically rule set. So basically do is divide the sample which have the most information gain for the algorithm, and it do it recursively with the sample until unless the requirement is satisfied. Okay, so it will just split its sample, and depending on the field is the highest information gain. So basically it's just splitting the high information gain field field node recursively. So we have also the codes. Okay, so here we can see we are using sklearn tree to classify the things, and we have a test split. It will split the high information gain yield, and this is the matrix. Okay, so firstly we are loading arrays to have a data, and after that we have splitting the data set using the random instead of 42 that has the not the much randomness. And after that the decision tree classifier is used, and the criteria is entropy that has a random state 42. So we will fit this extend and right hand that we have here and here, and then we will evaluate the model by using the prediction. We will use this X test here, which is comes from the splitting, and the test size 0.3. So after, let's see what it will give. It will give the precision of 1.0 from 0 and 1 from 0.93. Okay, it's also using F1 score. So the accuracy can be seen as 0.98 or 0.97. This has the maximum accuracy as I can see. Okay, so our next topic is how to build a random forest. So random forest is a concept where we have the multiple decision trees simultaneously that predict the value, and the maximum majority wins about any value. That will be the output. So random forest is a powerful deep learning technique in machine learning. It works by creating a number of decision trees during the training phase. Each tree is constructed using random subset, and this randomness introduces variability among individual trees, reducing the risk of overfitting. So this can also reduce the overfitting of any data set. So we have the minimum possible of errors, like we have the maximum accuracy as possible. Okay, so it will just improve the overall prediction performance. So let's look at our random forest. So we have this pandas SPD. Again we are using the same thing. We are having a random forest classifier by using sklearn library. Okay, so we are getting the dataset, which is titled dataset from the GitHub user, and from that we are dropping the rows about missing target value that will be available, so we cannot have the less accuracy prediction. And again we are just relevant feature and target value, we are combining it. Nextly we have a mapping and handling the missing value with the median, and in place 2 means it's not temporary, it will be the permanent. And after splitting the data as in the previous code here, now we are creating the random forest classifier, so the estimators are 100 and the random state will be 42 as before. After fitting this we predict the x best, okay, and accuracy score will be taken from this. So let's see the accuracy of the this. So it has also an accuracy of, you can say, a decent accuracy 0.79, 0.80, and the F1 score is also good, okay, and the support is good, higher as before. Okay, so this is about how to build random forest. Okay, so okay, thank you, this is for this video, and see you next time.